Let's look at the science of rain and how raindrops form. First, we'll need the sun. When the sun shines on water on the Earth's surface, the heat of the sun warms the water, turning it into an invisible gas called water vapor. This process, the changing of water into a gas, is called evaporation. Because gases are lighter than liquids, water vapor rises up into the sky. And the further you move up and away from the Earth's surface, the colder the temperature gets. So in the sky, the water vapor cools and changes back into tiny water droplets. This change is called condensation and is the opposite of evaporation. Clouds are made up of tiny water droplets, so when condensation occurs in the sky, clouds form and grow. Let's take a closer look. When water droplets bump into one another, they stick together and grow in size. They continue to grow until they are too heavy and fall as rain. They even grow as they bump into one another on their journey from the cloud to the ground. And every single raindrop that reaches the ground is made up of 1 million of the original tiny water droplets. Raindrops fall on the ground's surface where the sun can shine on them, and the whole process happens again. This is called the water cycle and keeps water moving from the ground to the sky, providing the water needed for plants, animals and people to survive. So now you know.
Water. It's one of our most precious resources, but our water supplies are limited. 97.5% of the Earth's water is salty, and only 2.5% is fresh water. But over 2/3 of this fresh water is locked in the polar ice caps and glaciers. This leaves only 0.5% in our lakes, rivers and groundwater for agricultural, industrial and personal use. But due to pollution, the quality of this water is under threat. According to the World Health Organization, only 0.007% of the world's total water supply is safe for consumption, and this minuscule amount needs to be shared by the more than 7 billion people on the planet. And this water is not distributed evenly throughout the world. 1.2 billion people live in areas of water scarcity in places such as southwestern United States, India, Spain, North Africa, Australia and northern China. At the same time, demand for water is intensifying. Over the last 100 years, global population has tripled and water consumption has increased sixfold. But our total water supply has remained unchanged. More people are now using a lot more of the same limited amount of water. And what has driven this exponential increase in water consumption? A growing middle class in the emerging markets has been one key contributor. As disposable incomes rise, eating habits change, and people tend to eat more meat. It takes 1,300 litres of water to produce 1 kilo of wheat, and 3,400 litres for 1 kilo of rice. But 15,500 litres of water are required to produce 1 kilo of beef. And with continued population growth and prosperity, meat consumption is expected to double by 2050. At this rate, by 2030, total demand for water will exceed the available global supply by 40%.
The air around us is made up of many different gases, including oxygen, carbon dioxide, nitrogen, and inert gases. Oxygen and carbon dioxide in particular are important for the survival of living organisms. The amount of these gases in the atmosphere is maintained by the carbon cycle and the oxygen cycle, respectively. The carbon cycle is the cycle that maintains the amount of carbon dioxide in the atmosphere by continuously taking carbon dioxide from the air and releasing it back into the air. When green plants undergo the process of photosynthesis to make food, they absorb carbon dioxide from the air. The carbon element stored in plants is then transferred to animals that eat the plants. When plants and animals die, their dead bodies decompose and release carbon dioxide back into the air due to the actions of fungi and bacteria in the soil. In addition, all living organisms, including plants and animals, release carbon dioxide into the air through the process of respiration in their entire lifetime. Over a long period of time, the bodies of dead organisms become fossil fuels, which are used by factories, power stations, and vehicles. The combustion or burning of fossil fuels also releases carbon dioxide into the air. In summary, the amount of carbon dioxide in the atmosphere is maintained when photosynthesis, which is a process that requires carbon dioxide, is balanced by decomposition, respiration, and combustion, which are